In the previous class, we have stopped our lecture at this point, that is network flow models, and we have discussed the rules to construct this network flow model, or also known as precedence diagram, right? So diagram, we have discussed three examples. So we have drawn this, and we have also have seen this, and also this have told you to do it as an homework problem. Fine. Okay, and also we have, okay, I'll give a little bit crisp recap on what we have discussed in the previous class, because obviously today's class is in continuation with the previous one, right? So we'll be discussing PERT and CPM. That's okay, but for PERT and CPM we need to have this precedence diagram in hand, then only we can proceed. And also we have seen that there are two type of network flow models. The first one is activity on node and activity on arrow. So this is what we are looking at, is activity on arrow or activity on node. What do you say? Is it activity on node or activity on arrow? The diagram that you are seeing here on the screen, what is it? Anyone? No, it's not activity on node, right? What is this? Event, right? This is event. Event on node. Activity is on arrow. Yeah. So this is activity on arrow, AOA, or you can say event on node. Generally it is known as event on node. Okay, fine. So, and also we have seen activity on node as well, but I told you that even though event on node diagram is having some dummy activities, it is preferred for PERT and CPM analysis. And for line balancing, we will be going for activity on node. Okay, fine. And I think it's not very much required to give introduction about what is activity and node. We have seen already all these things. And one more important thing is that we will be drawing dummy activities, or we'll be using dummy activities only when it is required. Sometimes we might feel that there is a requirement of dummy activity here, let me draw that. But no, think wisely, think carefully before drawing the dummy activity. It's very important. It's one of the notes that are given. We have to use dummy activities only when needed, as minimal as possible. Okay, fine. And two important things were, the one important thing was dangling. Let's say if we have this kind of dangling around here, let's say. So what we are going to do, we are going to strike this off, and then we are just connecting this to this, and we are closing it off. Let's say this is activity J something. So this J, we are putting it here like this. So this is what is dangling. We are avoiding danglings. Please try to avoid dangling, and please try to minimize the usage of dummy activities. Those are the primary important rules that we have to follow. The rest of the rules that we obviously will follow. And please do remember, the dummy activities will come into picture only when two or more activities are having same start and end points like this, right? And in this kind of situation only, what we'll do, we will draw like this, we will draw like this, and then we will have dummy activity like this, right? So this is activity A and this is activity B. So here this is activity A, activity B. Of course, activity A is, let's say, 4 hours. Activity B also is 4 hours, and activity A starts at 9 o'clock in the morning. Activity A ends at 1 o'clock in the afternoon. Same thing B also will have, but instead of drawing like this, because this is not allowed, right? So what we will do, we will just draw activity A here, B here, and dummy 1 and dummy 2, which is having 0 time allocated to that. And also dummy activities will not consume any mental work or physical work. Fine. Having known this, let's proceed with the coming slides, that is PERT and CPM. So first we'll discuss about CPM, then PERT. In inventory, we have discussed that. What was that? We have discussed deterministic models and probabilistic models, isn't it? Yes, right. So we have discussed this deterministic and probabilistic models. And we have seen what is the difference between deterministic and probabilistic models in inventory control. What was that? What was that? Anyone who can just refresh me with that? What was the difference between deterministic and probabilistic models in inventory control? Do you remember? There was a, yeah, deterministic is determined, exact, you're right. So what makes in inventory control, I'm talking about inventory control. In inventory control, there was a clear distinction between deterministic and probabilistic models inventory control. What was that? We said something, if that is happening only, then it is deterministic model, and if that is not happening, then it is probabilistic model. What was that? Remember, demand rate and what was that? What was the other term? Demand rate and lead time are constant, right? Constant in deterministic models. In probabilistic model, demand rate and lead time are not constant, hence we are carrying safety stock. That's the reason why safety stock models, probabilistic models are also known as safety stock models, because we are going to carry safety stock models. So in this case also, we have two different models. Okay, for attacking this kind of network problems, there are certain activities and there are some events that are happening, and where events and activities comprising of all these events and activities is known as project, right? So if you have taken a project, obviously there are so many events and there are so many activities that are going inside, and everything is having some precedence. Until unless you complete this activity, you cannot start another activity. There are so many things like that, right? So now you have to solve this problem. And try to find out some critical path. Actually, PERT and CPM are trying to find out critical path only. Okay, PERT and CPM both are trying to find out critical path itself. But first, before that, we have to know what is critical path. Critical path is nothing but in activities there will be some activities. So in project, I repeat, in project there will be some activities which are very important. If there is any delay in that activity, that will reflect the complete project. How can I say this? Okay. If there are some series of activities, let me think of some example which is very easy and basic in nature. Let me take this example. Okay. You started your day. You had your breakfast. This is your having breakfast activity, and then you have to attend your class, right? And then you need to take some break, right? And then you need to attend some other class, right? And then you are attending some sports. Let's assume that you want to play something, the play time, and then that's the end of your day. Let's say this is your start and end. Let's assume that, like, obviously you have, I missed so many things, but let us assume that. But if at all you have some other activities that are going, what is that? When your class is running, there is some other activity which is happening. There is some other activity which is happening. Let us say that you were also doing some side project, and you were doing some simulations. Let's assume that you were doing some simulations, so that you prepared your code and you kept the code running. So without you're attending class, you're doing break time, class, all these things, some code is running, and so some other activity is there. So in this thing, breakfast is very important, and class is very important. Break also is important. Class 2 is important. Play is important. Let's say all these things are very important activities that you have to do. And let's say you can go from start to end in two different ways, isn't it? You can go from here. This is one way, and another way is this, right? So in these two ways, I will say the second, this is, let's say, the first part, and this is the second part. The second part is critical, because if let's say if your class instructor is not leaving you early, let's assume is not leaving you early, he took little 15 minutes extra, some doubt session, something was happening, so he has taken some extra time. Now it will reflect on your break as well, because the break time, let's assume that's a lunch time, so you have to have minimum 15 minutes to eat. So that 15 minutes was eaten by your class instructor, let's say, right? So it's the same thing like that. Today itself, what happened? I was supposed to start class at 6 o'clock, right? But I started at around 6:20. There's 20 minutes delay. If I started at 6 o'clock, I should have completed by 8 o'clock. And 8 to 8:30, you were supposed to have dinner, and then 8:30 to 10:30 you had another class, right? So as a delay 20 minutes here, let us assume that I have taken class till 8:20 because I have to complete, and let's say I have taken 2 hours completely. Now, as I left the class at 8:20 and we had only 10 minutes to eat, so you couldn't do that. So because of that, you couldn't join the class, and of course there will be effect on the next class, right? You will be starting the class around 8:40, 8:45, I don't know, right? So that delay, what is happening, and that event which is creating that kind of delay at the end towards the total project. Let's say you expected that I will sleep by 10:30, but because of all these delays, you slept at 11 o'clock, right? So that activities which are very important, which will cause in which if there is any delay in that activity, is completely leading to the final time, project time. Let's say you assume that project time is 300 days. There are some activities which are affecting. Let's say some activity, instead of doing for 10 days, you did for 20 days. Because of you doing this for 20 days, your project time extended till 20 days. It means that whatever the extension that you did in certain activity is leading to the final project time. That is what is critical path. Are you getting what was the critical path? Is it clear? The critical path, meaning of critical path, that by definition itself, what is that? There are some activities which are very important, and if some delay that is happening in that activity will reflect in the final project time. That is the critical path. Fine. Now I was mentioning about the deterministic models and the probabilistic models, right? That we have discussed in the inventory control, right? So in this case, we say that critical path method, what we are doing is a deterministic model, and PERT is a probabilistic model. In the sense, something should be, obviously, if deterministic means something should be constant or something should be fixed. What is that something? We'll discuss. What is that constant? Obviously, something is not constant. In probabilistic model, something is variable. So in this case, it's very easy. That is, that constant or not constant metric is time. Time is very important. In the sense, let's take this activity, right? So it is starting at some point ei, that is your event I, and it is ending at some point event j. For this example, let's say the movie starts at 9 o'clock. That is 9 o'clock is ei, and movie ends at 12:30. So ej is 12:30. TEIJ. What is TEIJ in this thing? What is TEIJ? TEIJ is nothing but the activity time. So the activity time is 3.5 hours, right? 3.5 hours. Okay. So how do you know this is 3.5 hours? How do you know this is 3.5 hours? Because movie is fixed, right? Because it's not a live thing. It's not a live concert. It's already recorded. They have done editing and then they have saved it in a format and they're playing it for you, right? It is fixed. It's not going to change its time, right? But let's say there are some activities. You watched a movie and you attended some live concert, right? So this is not fixed. Due to some delay, there might be some different. It might take 2 hours, 3 hours. We don't know. But movie is fixed, 2.5 hours, let's say. So if we are assuming that all the activities in a project, so many activities are there like this, so many activities interrelated. Let us assume that, right? Like this, there are so many activities. All the activities are having constant time, in the sense we are assuming it to be constant. We are assuming that live concept also, I told you, right? We are assuming that I'm damn sure that it will take only 3 hours, but it's not true in the real life situation, right? So we are assuming that the time is constant. Each activity time is constant. That is what is CPM, right? Deterministic model. Probabilistic model. What is not fixed? Time is not fixed. One minute, guys. Okay. So what happened? We are saying that this is probabilistic model. It means time is not fixed. Not fixed means there is a variability. So you will guess, right? Live concept. Okay, somebody says that it will take only 3 hours. Okay, fine. It will be done by 3 hours. Somebody says no, it's gonna rain. Maybe because of rain, some 3.5 hours it might take. Maybe somebody says that no, it will rain for longer time. It might take 4.5 hours. Like that, you have different estimate for different things. You can estimate. Different estimates are done. But in deterministic models, it's a fixed time, 3 hours. That's it, right? So you're not fixing on time. You're very doubtful about time. So when there is a doubt, then you have some time estimates. So there are 3 time estimates. There are optimistic time estimate, most likely time estimate, and pessimistic time estimate. So we're going to discuss that in PERT, but let us now concentrate on CPM, right? What is CPM? CPM is nothing but critical path method. So what are we going to do? What are we going to do with this critical path method? Is nothing but we are trying to find out the critical path. What is the use of finding critical path? We'll be able to try to find the critical path, and we'll be able to know what are the activities that are critical, so that we'll be taking extra care for that activities, so that those are not getting delayed. If they're getting delayed, what happens? The total project is getting delayed. So that is the reason why we are trying to find out the critical path. Is it clear? Is the problem statement clear? Important CPM? Yes or no, guys? Hello? Am I audible? Yeah, fine. Good. So for finding critical path, we have to do 2 steps. Step 1 is forward pass. Step 2 is backward pass. Both are computations. You can say forward pass computation. Next is backward pass computation. Okay. So for forward pass computation, it is like this. So you pick up, there are so many activities. Like this. You pick up any activity. Let us pick up this activity, and I'm just putting it here. Okay. That is what I've picked up. So for that activity, starting time will be something. Starting event start will be something. Event end will be something. And the activity time will be some value. Okay. So what I'm writing it? It is earliest expected time for event type. How early it can start. How early that event can start. And how early it can end. That is earliest expected time for event J. But for certain activity, the earliest start is this, earliest end is this for this activity. Okay. And what is TEIJ? TEIJ is nothing but expected time for activity. Expected. We are writing all this in expected. Okay. Fine. Now, for doing forward pass, what I'm doing, I'm just calculating E plus TEIJ for all the activities, right? And trying to find out the maximum of it. Okay. And sir, I didn't get, sir, like why we are doing this. Don't worry. We will take an example, and then I'll tell you what is forward and backward pass. In backward, what we are trying to do is nothing but this is as late as possible. As late as possible, how much late it can start. Latest allowable time. And for the start of this event, and latest allowable time for ending this event. Late, Initially was earliest, as early as possible, and this is as late as. Latest means not the new one. Late means latest. Late. Late. We are delayed. That is what the meaning of that. Late means latest means we feel that this is new. No, it's not new. Latest means not new. Latest means late, which is delayed. How much delay that is as late as possible can we drag this to start this event? How late we can try to end this event? That is what is the Li and Lj meaning. And Tij is the, obviously we know that is the expected time for activity Inj. Okay, fine. So for backward pass, what we'll do, we will Li minus Tij. We'll take all the activities Li minus Tij and find the minimum of that, and then we'll put in the box, and then we'll try to figure out what is float and all. Don't worry, we'll discuss that. So for that, I'm just combining this forward pass and backward pass in this equation. Okay, so for forward pass, I'm using this square as my object because I'll fill the value whatever I'm calculating, the maximum of Ei plus Tij. I told you, right, that I'll fill in the square box here. And if I'm doing backward pass, I'll fill the value here, that is minimum of Lj minus Tij. This was the thing, right? So again, if you're not understanding, sir, what is this? Okay, we'll go for an example. Okay, this is the example. Okay, so let us assume that let me block this. Let me block this so that you will be able to understand what I'm trying to say. Let me blocking it. Okay, fine. So this is not given initially, only this network diagram is given. Initially, the network diagram is given. Okay. Now, I want to find out the forward and backward passes, and I want to fill that square and circle values. So I told you forward pass will be using square and a backward pass will be using circle. See, don't expect that you have to use all this procedure in examination. Only here and there he'll be asking the values in between step. Like let's say if we are doing this is a whole procedure, right? They'll be asking a subset of that. They won't be asking the whole procedure. If it is gate, they'll be asking, but in HL exam they won't ask. So procedure is very important. Please try to concentrate here. Okay. So if this is the diagram that is given, network diagram. So let's assume that there is an event 1, right? There is an event 1, 2, and there is a time 16 days. Then 1 to 3. Then there is activity. This is, let's say, activity A, activity B, activity C, D, E, F, G, H, I. Like that, there are so many activities. And this is the starting time of the project, and this is the ending time of the project. So to find the critical path, I told you we have to do forward and backward pass. Okay. So for that, what I'm telling, we have to do the forward pass. So okay, let's do that. So for forward pass, I have to fill this step. So if you're starting this thing, obviously you start with 0 time. Your timer will be 0 when you're starting a project. So the first in a project, you have to start with activity 1. So the activity A is 16. So you started at this point. Now you can reach 2, right? You can reach 2 in a one place. Like you can go from 1 to 2 itself. You can go to 1 to 3, but 2 is having only one head pointed. Only one head, in the sense 2 can be reached only from 1. 2 can be reached only from array. I deleted everything. Just hold. Okay, fine. Okay, so box, right? 0. 2 can from activity from, if you want to reach from event 1 to 2, only it's through activity A. So what I tell, so this is 0, right, plus 16, right? What is that? So you can write 16 here. Okay, what is that? What was that? It was Ei plus Teij. Ei is 0 plus Teij is 16, isn't it? Right? That's the reason why I added this and then I got 16. Now what I'll do, I will put the 0. Fine. Now I'll go to 3. How can I reach 3? I can reach 3 only way, one way, that is from 1. So again 0, 0 plus 20, that is 20 I'll put here. This is 20. Okay. So that's the reason why you see at event 1 I put 0. This is 0. Event 2 is 16. So that's the reason 16 here. Event 3 is 20. That is 20 here. For event 4 also you can reach event 4 in only one way, right? You can reach event flow in one way, that is from 3. So here 20, what is there here? This is 20, right? This is 20, right? 20 plus 15 is 35, right? That is what I've written, 35. So this is also done. And for 5, if you see 5, there are 3 heads that are coming up, right? It means that for reaching the event 5, you have to reach from 2. You can reach from 2 to 5. You can reach from 3 to 5. This is a 3 to 5. And you can reach from 4 to 5 as well. 4 to 5. So from 2 to 5, if you are calculating EI plus TEIJ, what is that? 16 plus 15. 16 plus 15 is how much? 31. From 3 to 5, 12, sorry, 20 plus 12, that is 32. And from 4 to 5, that is 35 plus 5. So it is 40. So maximum of 31 plus 32 plus 40, right? So that is 40. That's what I've written here, 40. So that's the reason why I have put 40. So this is 40, like this. Okay. And event 6 also you're reaching in 3 different ways. That is from 5 to 6, 4 to 6, and 2 to 6. Then calculate all the values. That is 52, maximum of 52, 55, and 40. Then you'll get 55 as maximum, and you will fill 55. So if I just erase all the things, if you see only the squared one, 0, 16, 20 is written, 40 is written, 35 is written, and 55 is written. That is what is the forward path that we have done. Any doubt in this? Let me know, I'll explain again. Any doubt? Hello? Please, there might be some confusion. Please let me know if there is any doubt. Why we choose the critical path, I'll tell you. But did you understand the procedure of forward path? Okay, fine, good. Okay, don't worry. If you are missing in the middle when I'm explaining the backward path, you'll understand. Okay. So now 55 is the max project completion time. This is your project completion time. Okay, fine. So now the same value will copy into this backward, because you have to start from back now. Go from back. 55 is copied. So you have to go from back here. So you're going back to 5. So you're going back to 5. In the sense, how can I reach 5 in backwards? Only one way, because only one tail is there. Because 5 to 6, only one tail is at 5. 5 heads are there, but you can reach back. You can reach 5 in forward pass in 3 ways, like this. But backwards is only one way. Right? So what was the backward pass answer? Answer was nothing but that Li. What was that? Lj minus Te plus Ij. So you can just write as 55 minus this 12 minus 12 will give you 43, right? So like that we are doing backward. So for event 6 already we know 55. For event 5 we are writing 43. For event 4 there is 4 here. This 4, how many ways it can reach backwards? We can reach backwards in 4 by 2 ways. It can come backward from 5 to 4 like this. Can come backward from 6 to 4 like this. It means that you have to calculate Lij minus Teij in both the cases. That is from 5 to 4 backwards, and another is 6 to 4 backwards. If you are doing for 5 to 4, that is 55 minus TEIJ is 20. Sorry, that is backward 6 to 4. Okay, 6 to 4. 55 minus TEIJ, that is how much? 35. That is 55 minus 20. 55 means you have to take the violet one. Okay. And for 5 to 4, 5 to 4, you are coming like this. So 43 minus 5 will give you 38. And you have to choose the minimum of these two, that is 35. So that is the reason why for 4, minimum of 38 comma 35 will give you 35. And that 35 I have written as here. This is what I have written, 35. Fine. Like that for 3 also, how many ways you can reach in 3? Only I think you can reach from 5 to 3 and 4 to 3. Like that you calculate the minimum of Li minus TEIJ. Sorry, Lj minus TEIJ. Minimum of that. Like that you can keep on proceeding till 1, and once you reach the 1, you get 0 and 0. If you're not getting here 0, means you did some mistake in the backward pass or forward pass. Okay. So like that you did forward and backward pass. Now you got some values here, right? Yes, in backward pass we are considering minimum. In forward pass we are considering maximum. Is it clear, Praveen? We have, because I have shown the formula. See, in forward pass we are calculating. In forward pass, what we had EEI, and we are adding all these things and we are calculating EJ. Then we are using maximum. And in the backward pass, what we did, so forward pass already, in forward pass already what, okay, in forward pass already we have calculated all the EIs. All the EIs have been calculated. Like that. In backward pass, what we started, let's say this is some event, some K. Then we just copied it here. That is EK in circle. And then we are going backward and calculating all the L's. Okay. So when you're going forward, you are taking the maximum of EI plus TEIJ. Right? When you're going backward, you're taking minimum of LJ minus TEIJ. Like that. Is it clear, Praveen? Yeah. So now we calculated all the forward and backward passes. So if you take any activity like this is the activity you take, you have all the values. Let's say if you're taking from 1 to 2. So this is 1, 2. You have to write the square one on the tops. EI is equal to 0. And here EJ is equal to 16. And here Li is equal to 0. Lj is equal to 28. Isn't it? TEIJ is 16. Like that we have covered all the values. If you want to take any other activity, let's take the activity of 3 to 5. You take this activity of 3 to 5. Let's say if you are taking from 3 to 5, sorry, 3 to 5. Okay, the square 120 EI. This is EI. EJ is, what is EJ for 3 to 5? Anyone? What is EJ for 3 to 5? Anyone? Hello, guys. What is EJ for 3 to 5? Hello, is anyone here? Yes, 40. You're absolutely right, Guna. 40. Right? And what is Li for 3 to 5? Li. What is Li for 3 to 5? Li. Isn't it 20? Because this is what is Li, right? Yes. And for Lj it is 43. This is what 43 is. Like that, for each and every activity you have EI, EJ, Li, Lj, TEIJ. That's it. Now the difference between these two, because this is the earliest, this is the latest, as late as possible. Earliest is 0, late also is 0. So you have to start on time. You're not allowed to delay. And this is what is one of the event which is having no delay. And there is another event, there is no delay. There is no delay. There is no delay. So where there is no delay, you pick up all the activities and join that activities. So, find the events and join the activities. Join all the activities in double line, and that path is critical path. And wherever there is no difference between this square and circle, here there is a difference. How much is difference? I think here the difference is 12. Here the difference is 3. Here the difference is 0. Here the difference is 0. Here the difference is 0. Right? Like this. Right? So what I'm saying is that if you are delaying anything from 1 to 3, if you are delaying anything from 3 to 4, if you are delaying anything from 4 to 6, the total project completion time will affect. Generally, it should be originally it should be 55. If you are delaying it here, instead of doing it for 16 days, you are doing it for 17 or 18 days. It doesn't matter, because as late as possible is 28. You have buffer. The buffer is allowed here. The buffer is of 12 days. 12 days you can delay. You can happily delay. Here also 3 days you can delay, right? But here there is no delay. 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 If you are delaying something in these 3 activities, then there is a problem. Okay, and that is the reason why this is known as critical path. Is it clear? Somebody was asking why, sir, why choose the critical path? Is it clear now? We are choosing critical path for these reasons. Yes or no? Yes. I think Naveen has asked this question. Okay, fine. Very clear. Very good. Very good. If you're clear, I'm happy for that. Now, sir, this forward and backward paths are very difficult for me, sir. I don't want to do all these things. Yes, actually, there is a very shorter way for this, but I didn't tell that. Now I'll tell you. How many ways are there? How many paths are there? I can start here and end here. Anyone who can say that? How many paths are allowed? I can go from. I can. I'll take the highlighter and maybe I'll take some very light color. Okay, this. I can go 1, 2, 5, 6. One path. I can go from 1, 3, 4, 6. Another path. I can directly go from 1 to 6. Right? And I can go from 1, 2, 3, 5, 6. This is another path. Right? Or I can go from 1 to 1, 3, 4, 5, 6. This is another path. Right? There are so many paths now. In this path, you have to find the maximum time. If you calculate the path, if you are calculating this as this is the path, what is the total time taken? What is the total time taken? Anyone? What is the total time taken? 16 plus 15 plus 12. That is the activity, right? 16 plus 15 is how much? 31. 31 plus 12 is how much? Anyone? 43. So 43. 43 is 1. And if you are another path, so the another path is what? 1, 1, 3, 5, 6. Let's say. What is that? Tell me what is the total time that is taking? 20 plus 12 plus 12. 44. Fine. Good. So we had 43 and 44. Please remember 43, 44. Now we had another path 1, 3, 4, 5, 6 like this. How much for this? 20 plus 15 plus 5 plus 12. How much is this? 35 plus 5, 40. Isn't it 52? 52. Right. Now we'll take another path. So we have 3, 43, 44, 52. And we know the critical path itself. How much is this total? 20 plus 15 plus 20. Isn't it 55? Yes or no? How much is this? 20 plus 15 plus 20. 55. Good. So we have fourth path. And last path is this. How much is that? 1 to 6 only 40. Isn't it? Fine. So in all these things, what is the maximum one? The maximum one is the 55. The 55 is occurring at this path. So instead of doing all this forward and backward paths, you can see all the possibilities. Try to calculate all the time that is happening in all the paths, right? And then select the maximum, and wherever the maximum time is coming, in which path the maximum time is coming, that is what is the critical path. So that is the another method where you can find the critical path. Okay. So that is the critical path. So that's how you have to find critical path by using forward and backward path, or maybe you can use this small trick. So here I didn't mention yeah, for backward it is the minimum. This is the formula. If you want to write, this is the formula minimum. Okay, and for forward pass it is the maximum. This one. This one. Good. Now, so we have already what we have shown is this thing, right? We have seen that earliest start time, latest finish time, EFT, right? So all these things. Okay, let me erase. Okay. So this is EST is EI, right? Earliest finish time EJ is EST plus this thing, this TEIJ. I didn't write TEIJ. TEIJ is here, right? And latest start time is LFT minus, because see for EST EFT we are adding here, for LST we are subtracting. This is what we are doing, because LST and LFT are found out by backward pass. That's the reason why we are subtracting. For forward pass we are adding. That's the reason why we are adding here. Same thing. Okay. And the important terminology here is this float and slack. Float and slack, in a sense, don't get confused. Float and slack is nothing but the extra time that is allowed for an activity. Okay, the extra time allowed for an activity. So for this activity, the extra time allowed here can be here. Sir, how come it can be here? Because you can start as early as possible, as late as possible for this activity, or you can end lately, right? As earliest possible you can finish, or as late as possible you can finish, right? So these are the four values which are denoting. So let's say you can write float as difference of these two, because how much is the time that is allowed to end late for this activity. I can, as early as possible I can complete by 6 o'clock today, as late as possible I can complete by 9 p.m. today, as earliest as possible I can start at 8 a.m. in the morning, as late as possible I can start at 11 o'clock in the morning, like that. So subtract these two, this will give you float, this also will give you float. It might not happen that these two are same. There are some places where these two are not same, might happen. And this float is activity oriented, and slack is nothing but same formula, but I am denoting in a different way. Why? Because we are dealing with PERT and CPM. We are dealing with PERT and CPM. Okay, that's it. And this slack is, see, a slack denotes the amount of time by which a particular event can be delayed without delaying the project schedule. Same thing here also. Sometimes it's the amount of time network path or project can be delayed without delaying the project schedule. Everything is same. Both are same and having different values. This is earliest allowable. I'm saying probabilistic, right? This is event based and this is activity oriented. Fine. Now, so total float is the float that is availability. So what is the total float? I can end as late as possible, right? And I can start as soon as possible. I'll start as soon as possible and I'll end as late as possible. This is, let us say, our sleep. Let's say we are very lazy. I will sleep as early as possible. 10 o'clock only sleep in the night. I will wake up as late as possible. 11 o'clock in tomorrow morning. As late as possible. Okay. But this is the activity time. Let's say you want to sleep only for 8 hours. After 8 hours, you are unable to sleep, let us assume. So as early as possible, you went to bed. At 10 o'clock only you went to bed. You slept for 8 hours only. And as late as possible, you woke up when you got out of your bed 11 o'clock. So let's assume that you went to bed at 10 o'clock in the night, and you came out of bed at at 10 o'clock in the morning, let's say, and you slept only for 8 hours. The rest 4 hours, whatever is there, is your free time. Maybe you read some novel here, Maybe you woke up in the morning and you played with your mobile in the bed itself. You didn't come out of your bed, right? So that 4 hours is your free time, float time, because that 4 hours didn't affect your total day schedule. That's the reason why total float is Lj minus Ej minus TEIJ actually, but I've taken minus common and I'm writing Lj minus EI plus TEIJ. So that was this total float. Total time that activity can be delayed without delaying the project schedule time. And total float can be positive, negative, zero as well. Positive means you have surplus time, surplus resources. So during that time, let's say if there is this project, let's say if this activity is of constructing some pillars, you have some time. It can be completed a little late. So what you'll do, there is some other activity which is very critical. Then you send some labor from here to that place so that you work there because that is important now. So you can hear that things are going a little slow because you have some gap, right? You can take some liberty here, right? And it can be negative. It means that your resources in the sense like manpower, machine, everything is included in this. Resources is not sufficient, activity may not be completed on time. If activity is not completing on time, then obviously it will be reflecting on the project. And if it exactly zero, then you are on time. Perfect. Dot. Okay. Now, in total float, we have some divisions, right? So this is called as free float. The total float formula is this. Please remember. But before that, you have to do this forward and backward pass. So please do know why I told forward and backward pass, because for making forward and for making this total float, free float, safety, sometimes in examination you might ask for activity J of activity 1 to 4, find out free float. He'll ask in exam. And for that you have to know all this writing. You should know how to write, how to make this EI, EJs, all the earliest times and all the latest. All the earliest times will come from the forward pass. All the latest times will come from the backward pass. So you have to know that, right? That's the reason why I explained all the things in the previous slides. Okay. Now the formula for float or free float is nothing but it is the extra time ever available with activity without affecting its successor activity. In the sense, what is the extra amount that is available here, so that is not affecting the next activity, not the top project, next activity. It should not affect the next. It means that next activity should start on time. That is what is important, right? So that is what is free float. And safety float is nothing but, and the formula is this, that is Ej minus Ei plus Teij. You should remember this formula, there is no other way. Safety float, what is the extra time available for starting any activity beyond LST of ith node, beyond latest start time of ith node, without affecting the latest finish time, latest state of net. So it means that how much delay I can do so that I can start even beyond this LST, but before this LFT. Can go beyond this LST, but you can, should not cross LFT, should come below LFT. That is what is your safety float. Okay. Next, and the formula is this, that is SF. And independent float is what is the surplus time available with any activity without affecting any time of earliest and latest time of successor activity. Okay. Here we have seen that it is affecting the successor activity. Here it is what? Surplus time available with any activity without affecting the earliest and latest time of the successor activity. In the sense, these two should not be affected in independent float. In free float, this should not be affected. Earliest start time should not be affected. Okay, that is very important. So this is the formula for independent float. So and one more important note, that is total float, the initial one plus independent float should be equal to free float plus safety float. This also might be a question. He will give you total float, independent float, free float, then last safety float. This is the equation. Is it clear, guys? The floats that we have discussed, because this might be a question. This can be a question in HL as well. Somewhere he'll give full diagram, all the values are given, then just ask you what is independent float for so much activity. You should be able to do that. Can you do that? Yes, very good. Next, critical path. So this is what I've been telling you. It is termed as critical because if any activity in the path is delayed by certain amount of time, the whole project is delayed by the same amount of time. I told you, right, in the previous so many slides. I've told you again and again that you should find some path where that activities are very critical. If something is happening in that activities, then it will reflect towards the end of the project. Okay. The activity for which the total float is 0 is known as critical activities. Total float, I told you, right? We have marked. This is what is total float. Total float is 0. Total float is 0. Total float is 0. Total float is 0. Right? Are critical activities. Combination of critical activities is critical path. The activities along the critical path are known as critical activities, and they are represented by double arrow. So we also have written as double arrow, isn't it? See, double arrow, black line, red line, black line, red line, black. So we are just highlighting the critical path by double arrow line. Fine. Now, so this is a problem. Anyways, we are not going to solve. So all the things have been written in this beautiful problem. So what happened? We have taken all things, and then we have put all the activities like this from A to K, all the event activity times, all the starting ESTs, all the EFTs, all the LSTs, LFTs, total float, free float, safety float, individual float. For all the activities we have calculated. This is an exercise for gate, but we don't have much time because for doing this problem it will take around half an hour, more than half an hour sometimes. Okay. So fine. So that's the end of critical path. So and what is the point here? See, every time we are discussing activity, it says here 2 days, 7 days, 8 days, 3 days, 6 days, 10 days, 6 days. How do you know? Is it 2 days? Are you sure? Is it 2 days? It can be 3 days also. It can be 4 days. It can be 1 day. We don't know. But as we are assuming that the time is constant, deterministic, that's the reason why here we are taking deterministic time and we are doing it for CPM. But if we want to deal with probabilistic, in the sense I told you, the time estimate for this activity from 1 to 2, there is an activity. That activity need not be 2 days. It can be some time. I'll say 1 day. You might say 2 days. Somebody will say 3 days. Right? So instead of having confusion, the developers of PERT have come to a conclusion with this. Like we are assuming some 3 time estimates. So three time estimates are this. That is, so it is uncertain in an uncertain project. So what is uncertain project, sir? Something new. Okay? And please remember, we'll do PERT for some R&D, research and development programs. CPM for some already known projects. Let's assume that you want to lay a road from some point X to some point from one city to another city. From decades, from centuries, we have seen that people are laying roads. We know even the technology is coming, so we know that what exactly on average we know. So it is deterministic because we have already done that so many times. But in PERT, let's say we are trying to lay a road from one ocean to another ocean. It's very crazy, but let's assume that nobody has done that, right? So if nobody has done that, it's a research and development problem. So the project is uncertain. We don't know anything. So when some uncertain projects are happening, in the sense why when the project will be uncertain, when the activities are uncertain, right? So during that, for each activity, I repeat, for each activity, 1 minute. Okay. For each activity, 3 time estimates are given. Somebody says, okay, we are, I mean, some crazy example I have taken, right? That is building a road from one ocean to another ocean. Very crazy project. Let's assume it's a hypothetical case, right? We'll assume that. So somebody says that first we have to, put the pillars. Somebody says that for laying all the pillars, it will take some 2 years. Somebody says 2 years. Optimistic. The guy says that yes, I am optimistic. Okay, for this, instead of this example, let's take one simple example for understanding optimistic, pessimistic, and most likely. The example every time I say this example only. So what is that example? Let's assume, okay. Yeah. Let's assume that you completed your college and you started from your college bus stop and you want to go to your home. This is your home. Okay, this is your college and this is your home, right? So let's assume you came by daily service bus. Okay, you came by bus and you want to go back by bus itself. So what I'll ask you a question. What is how much time it's going to take for you to reach from here to here? What do you say? How much time you'll say? Let us assume that the distance is 10 kilometers. On an average, for 1 kilometer, I'm taking 1 minute. So I'll take 10 minutes. So this is a deterministic way because daily you're doing that. Let's say you didn't do. Let's say it's not your home. It's your some friend's home. You never visited. You didn't go your to friend's home anytime. It's your new place. And now, if I ask you how much time it's going to take to reach your friend's home, then you will say some different times. Optimistically, you say, okay, I'll reach by. Pessimistic. What is optimistic? Optimistic in the sense everything is in your favor, right? There is no rain, there is no traffic jam. Once you reach the bus stand, the bus is ready for you, right? Everything is clear. Happily reached within 15 minutes. And pessimistically, you say, I might go to my friend's home by 30 minutes. Why pessimistic? Because you waited in bus stop for some time. There's a traffic jam. You waited some more time. Maybe there is a rainfall. All the things are happening. Bad things are happening. It's going on delayed. And you reached instead of 15 minutes, you took 45 minutes. Let's say that's the pessimistic time. What is the most likely time? Is the most likely some goods and some bads are happening. What is the good? You reach the bus stop, bus is ready for you. But once you got the bus, there's a traffic jam. Suddenly you reach some signal, but signal is green. Good thing happened. Again you're going, it has rained. Bus is going a little slow. So some goods are some bads are happening. Most likely you say I'll reach plus or minus some 30. So 30 is your most likely time. So did you get the point between optimistic, pessimistic, and most likely time? Yes or no? Is it clear, guys? How to estimate? How to give optimistic? Yeah. So in the previous case, we had only one time, right? Because you have activity, you have happily written TEAG only one time. But here in these three times are there. One is optimistic, pessimistic, and most likely time. Sir, we have three times now, sir. How do you do the analysis? Which time you have to consider? Yes, we'll do that. Okay. So optimistic time is nothing but it denotes the minimum time required to complete an activity where everything goes according to plan. Pessimistic time, it denotes the maximum time required to complete where everything goes against the plan. And most likely time is the activity under normal conditions. Okay. So as I mentioned, which time to consider? You have to consider this time. This time. That is, in PERT, all the times are given. Optimistic time is given, pessimistic time is given, most likely time is given. So you calculate this value, that is TO plus 4TM plus TP divided by 6. That is your average expected time to complete an activity. So this will be a question, not might be a question. I'm telling you, this will be a question in your HL exam. He'll just simply give you optimistic, most likely, pessimistic, and he'll tell you to find out the estimated time. Or sometimes if he wants to go a little ahead, he'll say this is estimated time, this is the optimistic, and he'll ask you TM for some calculation intensivity. Okay. And one more important point that you have to note here is, as we are dealing with probability, the probability distribution will come. So if you remember in service level model, we have assumed your, the demand rate or whatever is following the normal distribution, isn't it? And then we have kept a mu, and then we made some standard deviation. So this is your normal distribution, right? In this also, we'll assume our activity to be beta distribution. Why beta, sir? All these things. There's a proper way. The PERT developers have chosen this activity is following beta distribution in a very meticulous way. Actually, if you see the beta distribution of x and some mu, let's say the beta distribution is nothing but it is 1 minus it's x to the power of mu into 1 minus x to the power of 1 minus mu, something like that. I don't know. Maybe this is the equation. I forgot. Maybe it is something. I mean, I don't know. It is. I think this is, sorry. This is Bernoulli. I forgot the equation, beta distribution equation. But beta distribution is the distribution which can represent any sort of curves based on the values of x and mu that we are trying to, or maybe based on the values of a and b. But a, okay, I think it is x to the power of a to 1 minus x to the power of 1 minus b. I think like this. This is the equation of by divided by maybe some a plus b or something. I don't know. Some division constant is there. If you just type what is the Bernoulli beta distribution in probability, you'll get the equation. I think it will get something like this. I don't remember. So based on these values of a and b, what is x? X is nothing but probability of occurring. 1 minus x is probability of not occurring. This is for a binary variable. Okay. So if you're substituting a and b values, you'll get some different curves. Okay. So you can, if you are uncertain about which distribution to attach for certain activity or for certain process, beta is the optimal or the better one. That's the reason why activity is assumed to follow beta distribution. Activity alone, one activity, the process of happening that activity is assumed to follow beta distribution. So in that we have, this is the beta distribution like this, right? And if you see, we'll take highlighter. If you see the first point, this is your optimistic time as less as possible. This is pessimistic time as much as possible, and this is the most likely time under normal conditions. So if you are calculating this value, that is TE, that is TO plus 4TM plus TP divided by 6, then you'll get this. That is your TE value, and this is your beta distribution. Okay. So activity is beta. Activity beta. Please remember, this also can be a question. Gate also they have asked. Activity is supposed to follow dash under in options: beta distribution, Poisson distribution, normal distribution, Bernoulli distribution. They've given different distribution. Beta is the right answer. Okay. And I told you already. Here the important point is activity, and collection of activity is project. And as projects, so many things are happening. Everything is random. We are not sure about it. So that's the reason why it is following the normal distribution. So please remember, activity is following beta distribution. Project is following normal distribution. In the sense, the project time is following the normal distribution. Okay. So this is the activity duration and probability of each activity, and this is what is happening. But the probability, optimistic time probability is less. Pessimistic time probability is less. Most likely time probability will be more. Right? Right. So like that, if once we assume that there is a normal distribution, then we have to calculate the standard deviation of beta distribution. We have to calculate the standard deviation. So the standard deviation of single activity for an activity, please remember, it is pessimistic time minus optimistic time divided by 6. It is b minus a, because in the previous case we, instead of for TO, A also we have written TP or B, TM or M, right? Because of that, just TP or B minus A, TP minus TO, just follow any rotation and square it, you'll get variance, right? For this is for activity, a single activity. Please remember, for single activity. Like that we can calculate standard deviations for all the activities. And now we'll coming to project. Project is normal distribution. Obviously, this is full project. And this is mean. Mean is the expected time. What is this expected time? Expected time is nothing but the total project completion time. So what we have to do is that in PERT analysis, what we'll do is that we have some, let's say we have some, some activities like this. Some activities, like this. This is your total thing. So what you'll do, you'll calculate the total project completion time. So total project completion, maximum path, maximum time. Let's say this is your total project completion time here. This is what is T. And in each activity, what is the activity? What is the value that you write at each point? Each point is calculated by TO plus 4TM plus TP divided by 6. For each activity, you will have to calculate so and so values. It means that for each activity, the person has to give you all the values like this. See, activity A, optimistic time, most likely time, pessimistic time. Activity B, optimistic time, most likely time, like that you have to give everything. For that you have to calculate TE. How do you calculate TE? TE is nothing but A plus 4m plus B divided by 6. So just 4 plus 8 is 12 plus 24, 36 by 6 is 6, like that. Like that you can calculate. Okay. And then that is what is the estimated time. But project will have some scheduled time. They'll say that you have to complete it by some 100 days. This is the scheduled time. Right? So the schedule time can be plotted here, and the value can be calculated like this. Z, the standard normal variance, we can calculate schedule time minus estimated time divided by the sigma. This sigma is for project, not for activity. For project. So you said, sir, activity. So let's say this is your critical path. Sigma 1 will be there, sigma 2 will be there, sigma 3 will be there. So how to calculate the sigma for everything, sir? This is start point of your project, this is the end point of project. So it's nothing but sigma is equal to, for project, is sigma 1 square plus sigma 2 square plus sigma 3 square, where sigma 1, sigma 2, sigma 3 are the standard deviations for critical activities. These are all critical activities. Okay. Or else you can use area as your metric and then find out the area under ABS, the total red shade, divided by a total area. Total area is, what is total area? Highlighter. The total area is this. Total area. This one. This is total area. And what is area under ABS? ABS is this, only this till this point. This is your numerator. Okay. Fine. And for each Z, we have corresponding probability that we have to look from the normal distribution table. Corresponding probability of the calculator. So that is what is we have done in this problem. We have calculated everything like this. And this is your differences between PERT and CPM. Okay, differences between PERT and CPM. So PERT, I told you already, it is a probabilistic one. Let me take PERT is probabilistic, CPM is deterministic. PERT is event oriented and CPM is activity oriented. PERT obviously probabilistic and deterministic, we have told that. And PERT is having 3 time estimates because it is probabilistic, and this is only single time, deterministic. It is used where time required to complete activity is not certain, because some crazy project is there, R&D, research and development, we don't know, anything can happen. And these similar projects, construction of road, we have been doing that from long time, we know that prior experience and handling is required. And here we are not doing any cost analysis because we don't know how much, we don't know what is going to happen, and how can you estimate the cost? We are not going to consider any cost. But in CPM, we'll do something like crashing. It's called crashing. We'll do crashing. We're not going to discuss that here anyways. We're doing crashing. By doing crashing, we'll be doing some time analysis, okay, cost analysis, and try to reduce the total cost. And as I already told you, the application here is research and development projects on certain projects. And this is for mainly for construction. Even though if you go and see the civil gate syllabus, PERT and CPM will be there in civil CPM, especially CPM will be there in civil syllabus also. Some management. This is management course. Even civil department guys also will be having this CPM topic in their syllabus. Okay, so that's the end of PERT and CPM. Okay, so we are done with network flow models, PERT and CPM. Any doubts in this till now, guys? Okay, okay, fine. So now what we will do is that we will okay, crashing is still left. Sorry, I didn't discuss crashing, right? I think crashing, where it is there, we'll see that. Oh, it's here only. Sorry, yeah, it's here only. Okay, so this crashing model is for CPM. I'm not going to get into more details, but I'll tell you on a fly because it's a very iterative procedure, and I hope these questions won't be asked in a numerical sense, in the sense like they won't be asking any calculations, but they might be asking some concept questions, conceptual, theory bits, theory questions. So you should be ready for that. So crashing model is nothing but you have to reduce the product duration by maintaining the cost, or you have to reduce the cost. That is what is important. So, but both are inversely proportional. If time is increasing, cost will complete, because your time is increasing in the sense, sometimes if you're increasing time, the cost also will increase. Sometimes if you're decreasing the time, cost will increase. Anything can happen. We don't know. I'll tell you an example. Then you'll understand. Okay. So what you're trying to do is that initially I told you that please complete this by 15 days. Then I requested you, can you complete by 13 days? If I complete by 13 days, your total cost can go up, can come down as well. We don't know. How can it go up? Because you are wanted to complete in 13 days. You want to put extra labor here. Maybe that labor cost is more and your cost is going up. Or maybe it will come down also, because instead of doing it in 50 days, you are doing it in 13 days. Maybe some machinery or something like that, you have taken it for rent. Instead of using it for 15 days, you are using it only for 30 days. That 2 day extra rent is coming down, so total cost may come down. We don't know. So that is what the analysis we are going to do, right? We are crashing the total project from 15 to 13 days. Now what is happening to cost? That is what we are doing in the crashing model. Is it clear, guys, why we are doing this crashing? Hello? Yeah, good, good, fine. Now what I'll do, I'll just go through some basic understandings. I won't solve a problem, but I'll tell you some basic aim and understanding about it. As I told you, if your project duration, PD is nothing but project duration. If your project duration is coming down, total cost may go up. Your project duration is coming down, total cost may go down. That is what is the aim, right? Because crashing is nothing but you want to reduce the time. You want to reduce the time, right? So if you are reducing here, reduce. If you're reducing time, total cost may go up, may come down as well. We don't know, right? That was the aim. And in time, we have two different times. One is normal time, another is crash time. Normal time is what we had 15 days. Crashing time is 13 days, because we are reducing it. Crashed to 13 days. Obviously, normal time is always greater than crash time. Okay, fine. Now, so as time, we have different costs. One is normal cost, generic cost, that is your middle cost, independent of project duration. It doesn't matter. Let's say if you want to lay road from one place to another place, obviously it's going to take same amount of concrete, same amount of tar, same amount of cement, right? Every raw material is same. Doesn't matter, right? Because the distance is not changing, time only is changing, right? So this is independent of project duration. You do it in 10 days, you do it in 100 days. It doesn't matter. The same amount of cost material will be taken. Okay? And another is crash cost. Crash cost is nothing but the extra money that you're putting for extra resources. Because I told you, because if you are reducing it from 15 days to 13 days, maybe you have to employ little more, machinery. You have to bring some extra machinery, right? Obviously, how many days you are crashing, whether you want to do it in 13 days, whether you want to do it in 10 days, based on the reduction in days, your crashing cost will go up, right? It might come down also, we don't know, it will go up generally. Okay? And another is overhead cost, that is your labor cost, right? So instead of you're having 10 labors with you, each day you're spending 1,000 per each labor. It means that 10,000 rupees you're paying. In 15 days you're paying 10,000 into, it is that you're spending 15,000. I mean, 1,50,000, right? But if you're doing it in 13 days, then you're spending only 1,30,000. It's coming down, right? So that is what is overhead charges. So the total cost is normal cost plus crash cost plus overhead cost. Okay. And in activity also there is a limit. In activity also there is a limit. What is that? This is the normal time that it's going to take for single activity. This is the crashing time. In the sense, you can maximum reduce it to 3 days. So let's say this is an activity of putting the wires, railway wires, that overhead wires, electricity wires. You want to do it in 3 days, 5 days. Generally, it will take 5 days, but I'll try maximum. The maximum I can do it in 3 days. I can't go below that. So that is what is the crashing time. So how many days you're allowed? You can reduce for 2 days maximum. And obviously the cost is 1000 rupees here, and the cost is 1400 here, because you're doing it in 5 days. Okay, cost for this activity is 1000, but you're doing it in 3 days. Let's say the cost is 1400 crashing cost. So that's the reason why we are defining the cost slope. Okay, that is 1400 minus 1000 divided by 5 minus 3. This minus this minus this. That is what is here. This much is the crashing cost per day. 200 rupees extra you are paying per day. Extra, because instead of doing it in 1000 rupees, you're doing 2 days. You're reducing 2 days, right? Instead of doing it in 5 days, you're reducing it to 3 days. In this 2 days, you reduced. So for each day, you're paying 200. 200 is that. For each day, 200. 200 plus 200. That is 1400. That is what is 1400. Okay. So for each day extra, you're paying. Each day reduction, in a sense, for each day reduction, you're paying 200 rupees extra. That is what is cost slope or crashing cost per day. Okay. Next. So that is what I have represented in the pictorial form here, that is the graphical form. So on the y-axis we have cost, on the x-axis we have time, and crashing cost always will be less than the normal time, and crashing cost will be more than the normal cost. So the slope is nothing but delta c by delta t. Right? Delta c is nothing but cc minus cn. Delta t is nothing but tn minus tc. So that is what is your cost. Generally, ideally it should be something like this, but we are assuming it to be a straight normal cost. Normal under normal conditions. Is it clear? Normal cost, crashing cost, normal time, crashing time. Cost. Okay. Now, so I told you already, total cost is normal cost plus crash cost plus overhead cost, and there is a formula for that. This is the given value. This is not going to change, fixed, right? And crash cost is nothing but number of days crashed into crashing cost per day. That is what we have already seen, right? And over cost is that project duration. How much is the 13 days or 15 days? How much project duration into labor day? Labor 100 rupees, 1000 rupees per day, whatever you are doing. That is what your project duration, and this is what your overhead cost per each day. Okay, that is what is your. And then I'm not going to the details. This problem has been set, and then they are trying to reduce. You want to do it in 6 days. Generally, they found out that the project duration is 12 days, but you want to do it in 6 days. So what is happening? It is an iterative procedure. I'm not going to discuss here. It's a very lengthy one. Do iterations, and you found out that the total cost is around 147. Okay. Like that, we have some great question, and yeah, that's the end of your crashing model. So I didn't discuss the procedure, but I just gave the glimpse or a basic understanding of crashing that we are doing in the CPM models. Is it clear, guys? Yes or no? Yeah. Very good. So that's the end of your network flow modeling and PERT and CPM as well as crashing models. So take a break for 1 minute. Let me have water, and then we'll start forecasting and queuing and forecasting, whatever it is. Okay. We'll start that, and we'll see how long we can go. So your next class is at 8:30, isn't it? Isn't it? Your next class is at 8:30, right? So can I go till 8:10? 8:10? Is it okay? Can I take the class till 8:10 because I started a little later, right? I think 6:20. So I'll stop the class at 8:10. Is it fine? Okay. Fine. Thank you. So let me close this, and then I'll open The other one is forecasting models. So take a small break of 1 minute. I'll start the forecasting in the 1 minute. I'll start. Okay. Okay, Praveen, actually, I asked your Dinesh sir before. Actually, I thought of sharing them, but he he told me that you have to. If I give the notes, then you will not be you are not listening, because anyways notes are coming up. So he told me that let's not provide the notes, so that they'll be revisiting the videos and watch them, so that they'll be getting conceptually clarity. Something like that he was saying. But anyways, you just request him again. Possibly he might accept. Then I'll be sharing. Is it okay? Just ask him, because I can't, because it's his thing, so I can't share it. So you just ask him. If he's allowing it, then I'll share it. I'll share it to your Dinesh sir itself. Then he'll be sharing it to you guys. Please try to talk to him. Then if he's okay with that, then you can just discuss in. Yeah, I understand that. I understand what sometimes it happens, but it's very difficult. Just try to uh, 1 minute. Okay, so that's what, like, it's Dinesh sir's will and wish. You can ask him. Yeah, sure. You can ask him. So if he's accepting, then I'll share all the notes that we have discussed, like from right from beginning. I'll share all the notes. Maybe I'll share a Google Drive link so you can download all of them. Okay. Uh, we'll start forecasting, because I think we are left with 2 more lectures, because today is the lecture, and we have 2 more, maybe tomorrow or day after tomorrow. And I think I won't be able to take classes after from Thursday, because I will be traveling. So I requested Dinesh sir to stop my classes by Wednesday, so that I won't be able to take classes from Thursday. Okay. So tomorrow and after tomorrow also will be having my classes, and I'll be completing the syllabus. So today we'll start forecasting, and tomorrow I think we'll be most probably completing the complete industrial part. And the last 2 hours we'll be spending time for metrology inspection. And if possible, I will take one more lecture after the completion of syllabus, and then we'll try to solve the problems, only problems. Try to solve only problems, and I'll be able to answer your personal queries. Fine. So let's start forecasting. So what is forecasting? What is forecasting? It's a very common term that we use in day-to-day life, right? So the majorly we'll be using our forecasting for weather, right? Weather forecasting, isn't it? You go open Google and just type Bangalore weather, Hyderabad weather, Kolkata weather, Bombay weather, Delhi weather. It will, whatever the weather conditions that is shown in that is your forecasting. Maybe they are using some machine learning algorithms or maybe some deep learning algorithms, that is different. But forecasting is nothing but we are trying to predict something that's going to occur in the future, that's going to happen in future, right? That is forecasting. What are we forecasting? In our as we are dealing with industrial engineering in manufacturing sector, we are trying to forecast the demand rate, right? That is what is important. We don't know how much demand is going to come, right? So we have predicted some demand in inventory control in probabilistic models, isn't it? We have used the demand profit model, and then we have predicted the right demand. We thought like, okay, I'll keep so and so newspapers with me so that I'll be getting profit, isn't it? So this forecasting analysis is like that. We are trying to see the trend in demand. Because demand can be affected by so many things. It can be affected with seasons, it can be affected with government policy changes, it can be affected with weekly. So what is the weekly demand? Weekly demand, can you tell an example where the demand in a week is very high? In a single, let's say in a week, one day is having huge demand for something and rest of the days are not very demanded. Any example like that? One day is huge demand for something, some service or some product or something like that, and other days are very cool, nobody is caring about it. And weekly demands, any example for that? It can be monthly demand, it can be weekly demand, it can be seasonal. Festival day sweets, okay, that is not weekly, right? Every weekly you won't get festival, right? That is what is seasonal, what you're saying, seasonal or yearly, annual. Seasonal you can say, for each season you have one festival. Okay, I'll tell you movies, right? Yes, weekend restaurants, yes, weekend restaurants, weekend movies, right? So all these things can happen because weekends people are very hungry, they don't want to cook inside home, they go outside, have fun. Weekdays it's not like that because you are loaded up with work and you're not caring about it, right? So let's see the trends first. So let's see, before that we have to see the forecasting. So what is the forecasting? It's nothing but prediction can be forecasting can be termed as prediction of future sales and demand of a particular product. We are trying to predict the demand, but what can happen? Okay. And that can be done in two ways. One, we can use some past data, right? It means mathematically we have some numerical values and we are trying to see the data. Last 10 days something has happened, okay, maybe tomorrow this will happen. Last 1 month this has happened, maybe next month this also will happen. Last year this has happened, maybe this year will happen. I'm not sure. Supply chain management, I think they'll cover this forecasting. I'm not sure because I don't remember actually. I think I've done some course during BTech, but is it supply chain management? I don't know, but I'm not sure. Let me check it and let you know. Or else you can check it online. I'm not sure, but maybe they'll tell you. Maybe they'll explain this forecasting because forecasting is everywhere. Nowadays, everything is forecasting. What is machine learning? What is machine learning? Everything is forecasting is machine learning, right? What is machine learning? Artificial intelligence. Most of the machine learning is doing forecasting only, right? Right? And some of the machine learning things are doing some scientific things, especially in the engineering sector. Engineering and science. Forget about engineering science. Go to business and finance. Forecasting something is doing something. It's forecasting its business model, right? So we are learning with data. So that's what I'm saying. You can do forecasting with data, or you can do by judgment, human judgment. If you're well experienced in something, right? If you're well experienced in something, you can do that, right? So that is what is that? It's the projections of what is the projection? What is the projection? The data projection or the demand projection feature can be based on past data or human judgment. So what are the needs? So these are all the needs. I'm going to read that. Basically, why do you want to know demand in? Why do you want to predict demand in the first place? Because if you know the demand, then you'll know the volume of production or maybe the production rate, how fast I should manufacture. If I know how fast I have to manufacture, then I have to buy so many machines, so much labor, all these things. And it will also say the budget that you are going to allocate for that. Labor budget, material budget, production budget, all the things. And also design, right? number of people are interested, the design should be very nice. If the design is very loose, some other competitor will come, right? It has to be very strong. And let's say you already have some project, some manufacturing plant with you, and some demand is more, and your daily the machines that you had right now are not sufficient. So what you're trying to do, you're trying to expand your plant. That is plant expansion basically. And maybe you can establish some demand is more. Maybe I will put higher prices. Maybe I will say that anyways demand is more. I am the king of this business. Whatever price I set, it's the final thing. So I'll set some high prices and I'll get more profit, right? And it helps me. It's the same thing that if you see if you're ordering any food, or when I've seen literally if you're ordering any food in food apps like Swiggy, Zomato, or whatever it is. If there are some specific restaurants, they will never give you an offer, isn't it? Because they know that they are familiar and they know that they are good at that. They'll never give you offer. No discounts, nothing. Direct, you have to pay whatever the rate is. That price policy comes from most demand, because the most demand is coming because you're good in that, right? That's what. Some restaurants give you 50%, that percent, this percent, of course with a cap, because you're new and maybe your product is not that good, right? So it helps in deciding the extent of marketing, right? What is the marketing that you are going to do? Because if your demand is more, then you no need to do much market. If your demand forecasting is less, it means that it's not reaching so many people. You have to do more marketing, advertising. Okay. So all these things are needs and benefits of forecasting. Next is, I told you already, right? Like we have to know with time how demand is varying. Then only you'll be able to estimate that, right? The simple variation is trend variation. That is like you simply, the wave, simple as the demand starts slowly with time, very less demand, and as time proceeding, the small ups and downs are here and there, but globally you can see on an average you can see there is an increase in demand trend. For example, there is some mobile that you don't know. You don't know. You never heard of that mobile, but it started with some people who want to try that mobile have bought that mobile and then tried it, and then they gave good reviews in online. Maybe word of mouth. You're telling it to your friend, and your friend told to three friends told to 100 friends, like that. So somehow the product got very good reviews, and then people started buying it. Over the period of time, the demand is increasing. That is your trend variation. Simply, of course, ups and downs are there in between if you're zooming in. Another is seasonal variation. That is your short-term ups and downs. That is your weekend and daily demands. That is your movie tickets. Weekends demand is increasing. Weekdays no demand. Right? And cyclic variation, that we can see a wavy kind of thing where the demand variation is observed in yearly and per annum. That is what is winter woolen clothes in winter. Like winter is coming, woolen coats are demand is increasing. When winter is going, again no. Winter is coming, going, coming, going. Cyclic variation. Irregular variation is very weird variation where some kind of abnormal behavior is observed. Like suddenly a government policy change has happened, maybe some price hike is happening. Why price hike is happening? Because there is a war happening in Russia and Ukraine. We don't know. Because of that, oil prices have come up, right? So this is an irregular variation. We never expected Russia is going to attack Ukraine. Nobody said that, right? So that is affecting us now. Oil prices are going up. So this is what is irregular variation. There is some strike. Maybe there is a company. They went on for strike, or maybe there is a shutdown of that company itself because of something happened. So because of that demand variation, demand will suddenly spike up. Right now, the oil prices are going up, and you don't know today per liter it is 100 rupees. Maybe tomorrow it will be 110. So what you'll do today only you'll just fill your fuel. So that is what is your irregular. That is accommodated for the abnormal behavior. Okay. As already mentioned that the forecasting is divided into two things. One is judgmental, another is quantitative. So first is qualitative or subjective, another is quantitative or objective. So if you see the left hand side qualitative, in the sense you are not having any data with that. You don't have any numerical values with you. You have only uh, human intuition. Mostly human intuition will work with this thing. On the right hand side, if you see, there is a time series models. Time series models. What are those? The time series is nothing but, so the data is more important. The past average. You're doing something. What is the average? You're playing with some numericals. Some values are there, right? The numbers are there. In that also we have one more thing called causal or econometric, where we use some correlation analysis or regression analysis. So let's discuss this in a fly first. Opinion survey. You know that. What is opinion survey? What do you do? What do you do? You for a single product, let's say, once you buy, you are required to fill some feedback form. In the feedback, you'll be able to give your feedback saying that is the product good, whether product is fine with you. Maybe let's say it's a some product, some day-to-day product. Let's say it's a shampoo. Let's say, right? Maybe the product is good. Is the smell good? Is it working for your hair conditions? Is the dandruff going? Is the hair fall reduced? How do you rate our product? All these things are there in this thing, right? So based on the survey that has been collected from all of the users, then you'll be able to judge this product is doing good. Let us produce more. That is what is the prediction. No, this product is not doing good. Let us not produce more for some time. Let me do some more R&D and improve my product, and then I'll come back again. That is what is your opinion survey feedback. Market trial. This you might have seen this thing. What is that? You'll say buy one shampoo, you get a conditioner free. The conditioner, what is your market trial? And this market trial is used for some low cost objects only. You're not going to use it for high. You can't say that buy a laptop and get an iPhone free, right? You can't say that, right? You use it only for low consumables, low cost consumables. Okay? So what do you say? When you are introducing that conditioner as a free market trial, right? You're using it a free object. Then you see whether the thing is doing well or not. Then you remove it as a free, and then you'll put a MRP on that, and then you'll sell it. That is your market trial. So market trial also, you're trying to estimate the demand. Market research is one step ahead from the market trial, where you acquire, or where you go and take help of some third party, right? You take the help of some third party in the sense like you go to some consultancy company, and then you say that, okay, fine, please do research on this product and come back me and report. The third party consultancy company, it will go to each store or maybe each area, and they'll ask the retailers how the product is going, who are living around. Is it a rich person, poor person, middle-aged, middle income persons, right? And what is the average salary income of that so and so place? Because that is also important, because you can't go and put a Apple store in a slum, right? Nobody's going to buy. Obviously, you have to put in some kind of very high earning income places. And another thing is Delphi method. This is the most important method in all these things. This is based on your complete experience. How does this Delphi method work? Delphi method works in a specific way. What is that? You have, let's assume that we are in a business. Let's say we'll take some car business, and we all are expertised persons in that business, in that company. Okay? So you are from Delhi, I am from Hyderabad, somebody is from Bangalore, and somebody is from Chennai, somebody is from Kolkata. Like that, in each and every city, our main branch is there. In that, we are highly expertised people. And then what we'll do is that, to estimate the next year's demand, what we'll say, we'll all meet in one place. The regional office will meet, and then we'll have some roundtable conference. So we'll all sit in the roundtable conference, all the expert people, and then some certain questionnaire will be there. Some questions will be there. All of us will answer some questions, And initially we will not agree with each other. I will say some answer, you will be saying some answer, some answer. With that answer, some other questionnaires will be prepared, like second questions, second stage of questions. And over the period of time, we all will converge to one point, saying that this might be the demand in the coming year. So that is what is the Delphi method. So series of rounds will be there. Each round, some questions will be posed to some expertised people. Based on their answers, next round questions will be prepared. As we keep on moving, the diverse answers will be converged at some point. And that is what is your demand. And all these things remember, this and all are judgmental, human based, or human intuition or human experience based forecasting techniques. Okay, so that is what is using market trial, opinion survey, market trial. See, toothpaste, chocolate, cool drink, cosmetic items, all these things. And market survey, you're doing some. You're hiring some external, marketing agency, and then you're doing some analysis, and then you see customer occupation, location, quality, quantity, etc. Everything you're seeing. Delphi method is same thing. You have some round table conference, 6 expertise have come. Questionnaire is round 1, questions have been asked. Then round 1, somebody is saying 1000, somebody is saying 2000, somebody is saying 5000, like that. You have very diversified answers. Round 2, some conversions happen. Round end in the sense like it won't go more than 5-6 rounds. Then all are near some convergent answers, and then this will be your demand. Finally, you are at one point. And next is your, the time series. Let me not start the time series now because we have to discuss. We are at the end of your qualitative. Now we have to start quantitative. Let me not start the new topic here because I don't want to disturb the flow in tomorrow's class. So let me stop here, and from tomorrow we'll be discussing about this qualitative analysis. In qualitative, we have 2 more, right? Time series and Hausdorff. So we'll discuss 1, 2, 3, 4, 5, 6, all these things tomorrow. And forecasting errors is one more thing that we're going to discuss. And what are the topics that are left here? We are left with forecast, half the forecasting, queuing, sequencing, and little bit on lean manufacturing, and some production planning and control. In that, we'll be discussing something about aggregate production planning and material requirement planning. Okay, and then after that, the final thing, what is that left? Metrology inspection, a little bit of materials, and here and there we'll solve some good questions. Okay, hope you are solving the questions. I urge you to solve previous year engineering service examination objective questions, and also if there are any material science. That's what I'm saying. See, material science is very vast. It's very, very, very vast. I'm going to tell you some very, very basics, that too on a fly. I'm not going to dwell and go into depth because it's very time consuming. And also, I don't know, in GATE, material science is having very, 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 very least percentage of, what do you say, what is that? Least percentage of weightage. Okay, but I'm not sure whether HL is going to ask more questions in materials. It might happen, but I'm not sure. But as per, because they have mentioned it is GATE syllabus. GATE syllabus in the sense like maybe they'll take the GATE and they GATE weightage also. I'm not sure. Anything can happen. But anyways, I'll tell you some basics like heat treatment processes, a little bit on crystallography, FCC, BCC, HCP, all these things we'll discuss. Okay. Okay. So with this, let me stop for today, and please solve the questions again and again. I'm repeating, I'm requesting, urging, demanding, whatever it is. Please solve the questions. Try to practice more and more questions. In the class, I'm not doing the questions because we have so much concept to cover. If I'm doing problems, there might be a chance that I won't be covering complete syllabus in this limited time. Initially, I started off with solving some questions because I thought we can do. But over the period of time, I thought that that kind of thing will not work because some concepts have to be explained in a very detailed manner so that you'll be able to attack questions in examinations. Okay. So as Praveen said, you can, yeah, I think you can solve RKJN as well, but I don't know the standard of the questions. I didn't see that. I didn't see. Frankly speaking, I didn't solve any RKJN. But I request you to solve previous year engineering service examination questions because those are standard questions and very important, good questions. Although the syllabus is little ahead, but I urge you to solve them. Those are sometimes they might give the same questions. Okay. Okay, fine. You can solve RKJ. I'm not saying no, but I don't know whether the quality of questions are good in that or not. Okay. And sometimes HAL questions are asked from experienced people, like people who are setting the HL paper, might be asking questions based on their experience. That will come from severe practice. So please, the questions which are very generic, you should be able to solve. If the questions are little more experienced based, I think you should be able to select the option very what you say judiciously. You should not randomly select anything. You should think and wisely select. So to get that kind of experience, you should be able to practice more and more. Okay, let me not eat your time because you have very limited time for having dinner. So have the dinner and you can go back and start your next class. Thank you, and we'll meet tomorrow for the next.